Everyone, so now we are going to look fabric capacity planning. What is the fabric capacity planning? Network capacity planning means we need to ensure that our network resources, whatever we need, that should be run perfectly. We will not have any issue like bandwidth, not enough bandwidth, or if any issue, we will notice before happening that issue. So what we can say, in simple words, we can say ensuring that network has the resources it needed to prevent an impact on the business critical application. Means we will not have any issue with the critical application. We need to make sure that everything is good, no issue in our network. Example, whether you are ensuring that there is a enough bandwidth through the service provider, or verifying the load on the network device, having the full awareness from the single view. From the one point, we can see our network performance. With the one place, we can monitor how much bandwidth is utilizing, how much we are getting from the service provider. We can monitor everything. Generally, what we need everything should work smoothly in the enterprise network or any network. Everything should work smoothly. So what we can do, we can monitor each and everything, and we can check if anything is going wrong. Before going that down, we should have some idea. Like example, our users are using the more bandwidth, so we can ask with the service provider and we can increase the bandwidth. Depend the business to business. Maybe you will apply quality of service, maybe you will block some user. But in the fabric capacity, what we are saying, we need to make sure our critical business application should not impact, and we should not have any issue with the bandwidth or any other thing. We can aware with the single view. Single view means from one place we can view that one by using the SD-WAN, or by using the vManage, or by using the Cisco DNA Center. We can manage that one. We are going to see that one. So now let's see fiber network, fabric network. Fabric network is a overlay network. This term we need to remember. Overlay means logical, virtual network. Overlay means virtual network. A fabric network is an overlay network built on underlay network. First of all, we need to remember overlay. Overlay means logical, virtual network. Like you are configuring the VPN, you are configuring the tunnel, you are configuring the IPsec tunnel. Like that is virtual tunnel, not the real one. That is known as overlay. That is virtual network, logical, built on underlay. Underlay means physical, real network, physical one. So we need to remember this one. What we need to remember? Overlay means over means above the lay. That is virtual network, like IPsec tunnel, or we can say VRF, or anything what we are doing virtually, not physically. That is known as overlay network. Underlay means physical network. So a fabric network is an overlay virtual network built over underlay network, that is the physical network, by using overlay tunneling technologies such as VXLAN. VXLAN we are going to discuss in coming classes. We have some small topic for VXLAN, virtual extendable LAN, local area network. So we are going to discuss this in the coming classes, because the VLAN whatever we are using, that is not sufficient. If we look for the data center, if we look in the ISP, so we have the extendable, we can extend that one. That VLAN we can extend by using this technology. So we are going to see this one in the coming classes, what is VXLAN and what are the function of that one. Now we need to remember fabric network is a overlay network, that is a virtual network built over the physical network. And now by using this one, we have some issue. Whatever issue we have in the traditional network, we are removing that type of issue by using the fabric network. What issue we are removing? Like host mobility, means anyone can move from one place to another place. And network automation we can do network virtualization, and we can manually configure, and also we can configure automatically. We can send the configuration from one click, and we can we can access the network from one point. We can do configuration, we can design the template, and we can send the template. We have so many things with the fabric network. In the traditional we don't have that option. Now we have the many option available. Like we can use the SD access For the LAN enterprise network, for the campus we can use SD access. But for WAN connectivity, WAN means you are connecting one branch to another branch. That is nothing but WAN. If we want to do WAN network, we will use the SD-WAN, software defined WAN. And if we want to use the campus network, we will use SD access. We will see what is the difference between the SD access and SD-WAN. What are the different architecture? We are going to see that one. Now we need to remember, in the traditional physical network we have the issue. If you want to do the configuration manually, you need to do by using one by one, and it is taking lot of time. It is not secure, and also you will copy paste the configuration one by one. But by using the Fabric network, we have the advanced technology SD-WAN. We have SD access. With that one we can automate the many tasks we can manage, and we can do network automation. So we have two things. We have SD access Fabric and we have the SD-WAN. So what we can say, Cisco SD access Fabric is one of the main component of the Cisco's DNA Center. That is, DNA Center is nothing but Cisco Digital Network Architecture. Cisco DNA stands for Digital Network Architecture. Is a solution for the future intent-based network. Like with this one we can control our network. This is a controller. Just you need to connect this to our system and we can access this controller, and this is a GUI, graphical user interface application. We can look whatever is happening in our network, and we can send the configuration, we can read the configuration, we can perform with the Cisco DNA. So what we can say, Cisco SD access was designed for the enterprise, campus and branch network environment. Cisco, that is SD access. SD access is using inside the organization, that is campus or branch, not for the WAN. Not for the WAN. WAN means connecting the branches. We are not using the Cisco SD access for the WAN. For WAN purpose, we will use the SD-WAN. We will use the SD-WAN. So here what I mentioned here, same thing, not for the other types of networks such as data center and service provider and the WAN. Same thing here what I mentioned, Cisco SD access is only designed for campus, enterprise campus or branch network environment, not for the other networks such as data center and the service provider and WAN environment. We will not use the SD access. We will use the SD-WAN for the service provider or WAN environment. And traditionally we will use the MPLS over solution. We will use this like MPLS, VPLS, what we can say DMVPN we are going to use for the branches connectivity. But now what we are doing, we are using the SD-WAN. Why we are using SD-WAN? Because nowadays everyone is moving on the cloud. We have SaaS, that is a software as a service. Nowadays everyone is using software as a service. Everything is moving on the cloud like Microsoft 360 and other services like Azure. We have Azure Web Services, Google Compute Engine, we have Microsoft Azure, we have the Amazon Web Services. So everything is moving on the cloud. Nowadays everyone is deploying the application on the cloud. They are not buying the server, physical server and installing. They are just buying the server on the cloud and they are installing the application. So everything is moving on the cloud. So we have solution for this one is SD Fabric. So SD Fabric is a cloud-based WAN solution for enterprise and data network that were developed for addressing all new WAN requirements. So with the SD access and the SD solution, we will access our network, we will control our network. If your network is inside your organization, we will use the SD access. But if your network is outside your organization, means you are connecting two branches, we will use the SD-WAN for that one. And what is the difference between them means, I will maybe we can say what advantage we have in SD access, or we can say SD-WAN. Advantage what we will have means, we will have here controller. We are going to control from the controller. And for that one, let me show you one more thing. Like if you look for normal scenario, if you take router, switch or firewall, we will have three plane. We learned this in CCNA level. Already we know that one. All the device is having the three plane. One is the control plane we have, one is the data plane we have, one is a management plane. We have three plane. If you consider router or switch or firewall, we will have that three plane: control plane, data plane, management plane. Management plane we are using to configure. If you are using SSH, Telnet, SNMP, all this will come in the management plane. Why we are going to use the management plane? To configure the device. And if any routing protocol is running, that is known as control plane. Control traffic, that is a control plane, routing protocol, all that is running. And whatever our data is going, that is known as data plane. So we have three plane. So by using the SD axis and SD WAN, what we are doing, we are removing this control plane. We are removing the control frame from the router and we are keeping the separately. Let me repeat again. Let me take my blackboard. What I am saying, when we take any router or switch, we have three plane. This already we learn in the CCNA. Three plane we have. We have control plane, we have data plane, control plane, data plane, management plane. In the management plane, we will use this plane to configure the device. Control plane is responsible for controlling, like routing protocol, all the protocol. This is the brain of the router. One router, imagine one router is having three things. One is brain. Control plane is the brain of the router. Data means our data, whatever is going, and then we have the management, that is whatever we are configuring. So each router is having these three things: SD-WAN, software defined WAN, SD axis, software defined axis. What is the difference between this one? This is used for WAN connectivity. This is used for LAN connectivity. SD axis is used inside the LAN. SD WAN used in the outside the LAN. Just remember this way. Where we use SD axis used inside the LAN, means in your organization. Whereas SD WAN is used outside your organization when you want to connect to organization, to branches. We can use SD WAN. Both SD WAN or SD axis, what they are doing, they are removing the brain from the router. They will remove the brain from the router. Example, if you have 10 router, one router here, one router here, one router here, one router here. Okay, this is this way. When you configure the OSPF EIGRP, this guy is sending the update here, this guy send the update, this all are sending, they all are having the brain. With the brain they will think and they will say this path is good, this path is good, this path is good. They will enter in the routing table because they are having the brain. So what SD WAN, SD axis is doing, they are removing the brain from this router, this all router. They will bring the remove the brain. They will make one big brain, and this big brain is going to give the instruction to these devices. This device is now without brain. He is not having the brain. So this is the big brain, that is nothing but controller. That is the Cisco DNA controller, Cisco DNA controller for the SD axis. For the SD WAN we have the vManage. Controller name is vManage, vSmart, vBond. These three are the controller in the WAN connectivity. SD WAN is having three controller: vManage, vBond, vSmart. Three controller we have in the SD WAN. Whereas in the SD axis we have one controller, that is Cisco DNA center. That is one controller. So what we are doing, in simple words, if I want to say, we are removing the brain from our devices and we are keeping in the controller. Means controller is controlling the network device. Before each router is sending the update, they are doing the calculation, they are utilizing the, they are increasing, they are using their CPU. Not, they will not use their CPU. Whatever controller is saying, they will do that one. If you see here, let me check here if I have anything here. No, because in the CCNA level we have that one, but here I don't mention because it is not there in our syllabus, the control plane, data plane. Now just remember, any router is having the three plane: control plane, data plane, and management plane. Control plane is responsible for controlling the device, that is the brain of the device. Management plane is the plane where we will configure the device by using the Telnet SSH, that is the management. We will manage the device with the management plane. Data plane means he is going to forward the traffic. He is going to forward the traffic. Whatever traffic come, he will forward. So that is data plane. So what SD-WAN XD axis will do, they will remove the control plane from here. Now our device will have only data plane and the management plane, and control plane will be removed, and we will have the separate controller to control our devices. That is SD-WAN and SD axis is doing that one. Okay, so if you see as a software defined axis, the full form of SD axis is software defined access. So what we will have, there are many operational challenges in the enterprise camper network due to manual configuration of the network device. And whenever we are doing the manually configuration, we will have slow and we will have misconfigure. Sometimes we forget to write something. If you remember, when I am configuring anything here, sometime I do spelling mistake here. I miss something. Sometime I did not put this IP address. Sometime I did not put this interface. Sometime we will do. We are human being. We will forget. We will mistype. So what we can say, that is nothing but misconfiguration. So what we can say, there are many operational challenges in the enterprise network due to manual configuration of the network device. Manual configuration means manually we are writing. As we are doing, we will open in the real scenario also. What we are doing, we will open the notepad, we will type the configuration and we will save. We will go and we will copy paste. And if you have another device, just we will change the IP address. What we will do, just we will change the IP address. We will follow same script. One time we will write, we will save that one. Just we will change the IP address and copy paste. Just we are doing that one. Sometime we will have the misconfiguration and the slowness we will have. That will cause the interruption of the network. That will have the issue in our network, because nowadays no one need downtime. Nowadays no one need downtime. Everyone need, all the network should work each and every time. Means every time our network should work. Everyone want network should work smoothly. No one need downtime. So what we can say, we will have the many challenges if we do manually configurations. To overcome those types of issue, we will go for the automation, that is from the SD access or SD WAN or SD access. If we are using inside the network, we will say SD access. If we are using the outside the LAN network, that we can say SD WAN. So what we can say, we are growing, our users daily, new guys are joining in the organization, new endpoints means computer, laptop, printer, scanner, all that is nothing but endpoints. Example, if your company is very big company, maybe so many guys are joining in your organization. Your project is very big project. Maybe you are working in very big project. You are daily, your HR manager is hiring new guys. So you need to allocate the new username, password and new laptop, everything new, all endpoints are increasing. So you need to make the new user in the Active Directory. You will do so many things. You will assign the policy. Maybe in the firewall you will create the policy for that user. This guy can access this one, he cannot access that one. You are doing manually. As the user is growing, this task will be very complex. If you have many user, daily you are having new user, you will have the many network complexity you will have. And if policy are going wrong, if you have anything issue that user is unable to access, you will have issue. Maybe in the wire or wireless network you will have the issue, and you will have the security vulnerability, also weakness in the network. And we have so many issue. So what we do, we will use the SD access. So what advantage we will get by using the SD access? In the SD access we will have controller. From controller we are configuring. If you configure in the controller, you can push the configuration, it will go to our devices. So what we can say, in other words, traditional campus network do not address the existing campus network need. With the SD access, what we can do, we can build and address the existing network by increasing the capacity by feature, like what we will have generally when we open the dashboard. I don't have here SD WAN dashboard, but generally when we open, we will have the tabs. Like, let me show you, maybe in the internet that is available. Cisco SD, because this one we don't have DNA now, we have in the CCNA level. So Cisco give one dummy data login account also, we can log in and we can check that one. But anyhow, let me show you with the screenshot here, so you will have the idea. Like this you will have in the, what we can say, in the dashboard. When you log into the Cisco DNA Center, still some companies are not using, some companies are using. So when you log in, you will have whatever issue you will have, you can see the graph. You will see there is a health report in the Cisco DNA Center, that is SD access. You can see health report, you can see which guy is utilizing more bandwidth, what is the issue in the network. You will have the suggestion also. Like if you have any issue in your network, you will have a list of suggestion also available in that one. You can monitor each and everything with the Cisco DNA Center. So we have so many things in that one, we can easily track that one. So let me go to our notes. So what we are saying, network automation, network assurance, analytic. Network automation means we can automate, like if you are doing manually some task, now we can automate that one. Just click that one, automatically that will fetch all the reading from the devices and it will show you. Example, if you want to run show process, it will no need to go manually one by one device. When you click one tab, it will give you for all the devices. Network assurance, analysis we can do. And host mobility. Host mobility means the computer or laptop, anyone can move in the organization one place to another place. Before we are using the LAN cable, connect only one place, but now no need to connect with the one place. We have the identity service, that is Cisco ISE we have. So Cisco ISE is going to take care about the mobility, means one user can move in the organization. He can sit in the ground floor or first floor. It is not necessary this guy should connect to only this port. If he is connecting to any other LAN card, that port is going to go down previously when we discuss in the CCNA level. But now we have the solution for that one. Automatically, depending upon that user login detail, Cisco ISE is going to check and he is going to apply that policy, whatever policy is present in that one. So what we can say, we can do network automation. SD-Axis replace the manual network device configuration with the network device management through a single point of automation. Means you need to log into Cisco DNA Center and from there you can configure the all devices. No need to log in individually. Directly from there you can configure and you can analyze. You can check which router is using more, where more traffic is sending, and like which interface is having issue, more traffic, which interface is having everything, which endpoint is utilizing the more bandwidth. You can verify that one also. And SD-Axis provide you mobility also for the both wire and wireless, means that guy can move from one place to another place. We have identity service also in that one, that is nothing but Cisco ISE, Cisco Identity Service Engine. This is the what we can say, this is a virtual machine we can have, or the physical also we can install this one in the VM also. This is like a server, like a AAA server. He's going to check, like when you put the username, he will check you belongs to that domain or not, and you are authorized or not. They will check your operating system, antivirus, all are updated or not. If everything is good, then they will allow you to enter in the network. Means when you connect your laptop to your LAN cable, and when you put the password, login detail, that will go to switch will send to Cisco ISE. Cisco ISE is going to examine your all what we can say, your device examination, like they will check antivirus, your operating system is up to date, all the property whatever set in the Cisco ISE, they will verify. If everything is good, they will allow your device to access the network. And we can have the policy enforcement, and we can have security, we can have network virtualization in the SD-Axis by using the Cisco DNA Center. We are saying SD-Axis. What is SD-Axis? SD-Axis consists of two components. One is Campus Fabric solution, the one which we are saying overlay, underlay, that one, and another is the Cisco DNA Center. So what we will have, imagine this is our what we can say, this is our network. Okay, this is our network, this one, Cisco Fabric. This is our physical devices, this is our logical, and this all are called as Campus Fabric. And we have the Cisco DNA Center. This one, Campus Fabric plus Cisco DNA, is known as SD-Axis. So with this one, what we can do, we can connect our laptop to this controller from the Cisco DNA Center, and from there we can access this one. This is a web base. Just you need to type the IP of this controller in your browser and put the username, password, then you can access this controller. From there you can check the health of that one and all, you can perform that operation. So you need to remember, SD-Axis is nothing but Campus Fabric plus Cisco DNA. When we add these two things, we are saying that is a SD-Axis. And what we can do, we can access the Cisco DNA, and we can design, provision, policy, assurance, this all operation we can perform from the Cisco DNA. Cisco DNA we already learned in the CCNA level. So what we can say, we have the control plane, data plane, management plane, policy plane, everything will be available here, and the device Cisco DNA Center is going to perform. And here when we see here, when Campus Fabric solution is managed by using the CLI or by using the API or the network configuration protocol, that solution is considered as a Campus Fabric solution. So what I want to say here, whenever we are managing our network by using the CLI means console of the device. API means we can take the API is nothing but like a mediator. Like if you go in the restaurant, if you ask the waiter whatever you need, waiter will go and he will tell to the kitchen guy will prepare, and when it is ready the waiter will bring and he will give you back. Same thing like that. API is nothing but application programming interface. He is going to help you to bring that one. Means you can what we can say, API like application programming interface. Just like when you press, like we have so many API, you can have Amazon API, so many API. API is nothing but just it is a interface between you and the application. Like if you want to get some information from server and you are here, so you will fetch that in this is the guy who is going to get and bring that information. That guy is the API. This is a application programming interface between the client and server. So we can use the API. There is a API method. We are going to see API later in the automation. So we can access our device through CLI or with the API, application programming interface. We can access our device with any application. Imagine like by using Python script we can access the device. That is also we are using API. And we can use the network configuration protocol, that is netcon, YONG. We have, this is a network configuration protocol. If we are using this protocol to manage our network, that is known as Campus Fabric solution. If we are managing our network by using Cisco DNA, then we call that one is a SD access. This is a difference. You need to remember what I am saying. If we are managing our network, if we are managing our campus by using CLI or API or network configuration protocol, that is known as Campus Fabric solution. Or if we are managing our Campus Fabric solution managing via Cisco DNA Center, then it is known as SD access. And now we know what is SD access. It is a mix of the Campus Fabric plus Cisco DNA Center. So what we can say is Cisco SD access is a based on the existing hardware or software technology. So now we need to remember Cisco DNA Center. Cisco DNA Center is nothing but it is come under the SD access. SD access is nothing but campus, that is this one we can say Campus Fabric plus Cisco DNA. That if we mix, it is known as SD access, and it is having the what we can say different layer. We have the physical layer, we are the network layer, we are the control layer, we are managing layer, and we have the Cisco DNA here. We can apply the policy from the DNA Center. We have the Cisco eyes, we have the here virtual overlay. As we are saying, overlay means virtual thing, and this is our physical network. This is a physical network. Let me take, this is a physically all the devices whatever we have the Cisco, we have the DNA Center, we have the Cisco eyes, wireless, routers, switches, all this one. This is underlay. So this is all our underlay. Then we have the overlay means logical network whatever we have. Then we have the design basic policy, whatever policy, control layer, DNA controller, whatever policy they are using. DNA controller and SD that is ICE is using the decision to control the traffic. And here is a management layer. In that one we will have the tabs. We can check what we can check, what policy we apply, what is the assurance design we can do with the management. Means from management side we can just look and send the any commands to the device through a GUI. Okay, so what we can say, physical is nothing but having the switch, router, all the physical devices here, and network layer is having the network, that is underlay, overlay. If you see here you will understand more, underlay, overlay. If you see what we can say, underlay means underlay control plane. This is the devices, physically devices, that is known as underlay. Overlay means we are configuring like VPN, tunnels, anything logical, whatever we are configuring, that is known as overlay. Okay, and software defined as a WAN. So now we will see the SD-WAN. So what is SD-WAN, and what is the difference between normal whatever operation we are doing in SD access or SD-WAN? Simple, just we need to say whenever we want to perform any operation manually, we need to access device one by one and do the configuration. We will have issue misconfiguration, and we need to access each and every device separately, and we need to monitor, we need to configure. It will take lot of time, it will consume lot of time. That is the issue with the traditional network. Now we have the network automation, that is we have the SD access and SD-WAN. SD access we use in the LAN network. We have the Cisco as controller, that is the DNA controller, DNA center. With that one we can monitor, configure, control everything within the LAN. And then we have another technology, that is SD-WAN, software defined WAN. With this one we will manage. What we will manage? We will manage our branches by using the cloud also. So here we have two options. We can install the controller in the cloud for the SD-WAN, or we can use physically in our location, or generally ISP is using this one. Example, internet service provider, we will ask ISP, I need the SD-WAN solution to connect my branches. We will tell to ISP, and depending upon our contract, maybe ISP will install the devices in our physical location, or maybe it is available in the cloud. We can access, they can give you some access, like some level of access, depend upon the contract, whatever contract we done from the ISP. So now what we can say, SD-WAN generally why we are using to connect the multiple branches. And here same thing as I told, in SD-WAN we will not have the what we can say, let me show you here, this you will understand. Imagine you have here one branch, you have another branch, you have another branch. This is a different branches, your company branches, all these are the branches. Here you have only data plane, you don't have here control plane, you don't have control plane. All control plane from here we remove and we put here. So this is the device, they have the controller, this is a controller. You can have this controller in the cloud, or maybe in the ISP location, or maybe in your physical location, depend how you contract with the ISP. So what we will have here, see here, what you will do, you will install one router. Imagine this is, I am saying this is a branch. Branch means, imagine this is a core layer switch. As we told just now, I think, let me show you again that one. If you see this architecture, this is a core layer, okay. Imagine this one is a one switch, this one core layer, one the above layer, this one. This is nothing but one branch. I am representing this whole thing with a one branch. Let me show you here. This one, I am saying this is my branch. So imagine you don't think, maybe you are thinking only one router. It is not only one router. You will have one router. This is connected to internet, but after that you will have our architecture same as we have before, like core layer, like access layer, distribution layer, all the PC, printer. You will have all this inside here. It is not shown in this diagram, but you need to imagine this is your core layer switch which is connecting to the ISP for the branch 1. Imagine this is a branch 1, and inside here you will have all this like distribution layer, access layer, all this will be there, but this is a main thing. This is connecting to internet. So this will be connecting through internet with the MPLS, maybe with the 4G or whatever technology we have with the internet. So maybe this is your branch 1, and you have another branch, branch 2, you have branch 3. In each branch you will have all this architecture, but the above layer, the switch or the router, whatever router is connecting to ISP, that will be representing here. So what I can say, this is my one branch, another branch, another branch, like this I can say this is my different branches, and this is, I can say this is my core layer switch or router which is connecting to ISP. But here in the SD-WAN technology, SD-WAN, SD-WAN technology, we call this one as a V-Edge router. V-Edge. So you need to remember, whenever we are installing the SD-WAN solution in our organization, what we will do, the ISP will install V-Edge router. V-Edge is nothing but that is a core router that is connecting to the internet, that is known as V-Edge. This will be connected to the 4G or MPLS or any media, maybe internet, maybe MPLS, VPLS, anything they can connect to the internet. So how they are making communication, how they will make the communication. So first of all, when you imagine you have new company, you open one branch here. Imagine you have one branch here, you install the V-Edge. Okay, we install the V-Edge. What we will do generally, we have the Cisco account, Cisco Smart account. We have Cisco Smart account. Okay, here when we buy from the Cisco, we will give our organization name and organization site ID to the Cisco. We will put that detail in the Cisco Smart account. There is a one account we need to create. We will not create, but in the real scenario, organization whoever is having the Cisco support, they will have this account, Cisco Smart account. In that one we will have all the detail about our devices, whatever we are buying, that is V-Edge, serial number is there, and organization name we will put there. So this device serial number is also there. Whenever we connect with the internet, and we will do some basic configuration, after that this device will connect to the internet and he will go to vBond. This device connect to the vBond. vBond is a controller. vBond is a controller. What he will do, he will authenticate, he will check the authentication between this V-Edge. Example, this is a V-Edge. So this V-Edge will connect with the MPLS or internet or 4G, anything it will connect. It will go to vBond. vBond will check the certificate authentication, everything is okay or not okay. If they will use the secure protocol, TLS, we are saying TLS, they are going to use the TLS, that is a transport layer security protocol, to make the communication. This is a secure solution, so they will use TLS protocol to connect them, and here this vBond will check this guy is genuine or not, if everything is okay, because the Cisco Smart account, in that one we will have this serial number, and it is mentioned this what we can say, it is mentioned this serial number, organization name and the site ID, everything will be available in the Cisco Smart account. So when we connect this one, it will go to Cisco Smart account, it will verify, and it will verify with the vBond. And we have the different solution, Webtela. Webtela is the Cisco SD-WAN solution. We are using the Webtela. Let me show you, I wrote somewhere here, I wrote Webtela, this one. Cisco SD-WAN solution is based on Webtela. This is separate company before, but now Cisco acquired this one. Now this come under the Cisco. So Cisco buy this company, Webtela. This is SD-WAN company. So now this is under Cisco. And we have Meraki SD-WAN also, but more popular is going this one, Webtela. So what we are saying, we will have this controller. Where is the diagram? This one. So what we can say, when we connected this device will go to vBond, and he will check the certificate. They will verify the certificate, like this guy is genuine or not. If it is genuine, then after that he will give the vSmart IP and vManage IP. Then he will go to vSmart and vManage. It will connect this V-Edge. This V-Edge will connect to vSmart and vManage. He will connect to vManage. He will get the configuration from the vManage, all the configuration, and then from the vSmart he will get the routing update. He is not having the brain. He will not think anything about routing protocol. All whatever this vSmart is going to give the decision. This is a controller. He will tell, okay, if you want to go to this network, go to this direction or go to another direction. All this one will be sent by the vSmart. vSmart controller is going to tell to our V-Edge. What we have actually, let me define first of all this controller. What controller is doing what, let me define. So what we have vManage. First thing, vManage, that is network management system, NMS. We can say NMS. So here in the single panel of the glass, that's GUI, graphical user interface, we can manage here. We can send the configuration. We have the one IP address for vManage. We will type that IP address in the browser. Then we will have the login detail, and we can go inside. From there we can manage. We have the GUI, graphical user interface, and then we can check how many devices we have under us. We can check, we can send the configuration, we can make the changes in the configuration through the vManage. Okay, this is a controller. Through this one we can manage, and we can change the configuration also. Then we have the vSmart controller. vSmart is the brain of the solution. Means we are saying I will remove the all brain of this router. This is router only, but high configuration. This is known as VH router. And here we don't have brain of this router. They are going to listen to the vSmart. vSmart is a brain. He is going to control all this one. He is going to send all the updates. Example, this guy, if this guy is having any network, he will send to vSmart. This guy having any update, he will send to vSmart. All guys are going to communicate to the vSmart. They are sending all the information to vSmart. Then vSmart will update us. Example, if this guy want to go to this place, he will check with vSmart. vSmart will say go this way, that way, whatever the route he will give, the vSmart is going to give that route. So that what we can say, vSmart is the brain of the solution. vManage, we can manage and configure through the vManage, through a graphical user interface. vSmart is a controller, that is the brain. He is going to send the route. So SD-WAN router. SD-WAN router is nothing but VH. We are calling that is the VH. VH means this will be present in our enterprise network. In our network, that is in our branches, head office, branch office, we will have only VH. Okay, VH or CH. These two different router we have. This is the VH is a solution from the Cisco Viptela, but if you have the different version, you can upgrade the software and you can use that one also in our solution, in the SD-WAN solution. That the different hardware, that is known as CH, but the hardware which is coming for this solution, that is known as VH. So what we can say, VH or CH is nothing but our that is our branch office branch where we install this router. This router is going to connect to the cloud. And then we have the vBond. vBond is nothing but authentication center. Whenever any device come up, they will send the information to vBond. vBond is going to check, and he is going to supply the SD-WAN smart, this one SD, what we can say, VS smart controller, as well as vManage. Means in simple, what I want to say, this guy is responsible to check if this SD-WAN router, that is a VH or VH or CH, when this come up, means when we power on this device and do the basic configuration and connect it to the internet, this will go and this will look for the vBond. When he found the vBond, he will make the communication with the vBond. vBond is going to cross check the certificate. If everything is okay, vBond is going to give the IP of the vSmart and vManage. vSmart and vManage, from there they are going to get this configuration and they are going to get the instruction from here. And we have vAnalyze. This one we can check the performance of our network. This is optional. We will use this one to check the performance of the network. So now if you see this diagram, you will understand. Imagine you have your branch office here. Okay, you have one branch office here, you have one campus here, you have data center here, you have another data center here, you have your home office or any office here. Now you want to connect this all thing. So what we will do, we will put one VH here, VH, CH or VH. We will put one VH. VH is nothing but router only, but the router which is supporting the SD-WAN solution, that router name is VH. So this is a VH. What we will do, we install VH here, one VH. Under this you have the normal architecture. You will have different routers, switches, whatever you have in your organization, that you will have under this one. But this is a main which is connecting the LAN to WAN. This is a core layer switch. You can imagine this is a core layer switch which is connecting the LAN to WAN. So this is a WAN and inside will be WAN, and this is connecting here. This is a WAN. So this all devices, this all VH will connect to the vSmart. vSmart is a brain of the device. So all this brain is now no more. This all brain is here in the vSmart. So what vSmart is doing? vSmart is giving the instruction to this all guys. First time when we install this VH, we will do basic configuration. What we will do? We will put the organization name, we will put the branch number, we will put the IP address, and then we will connect to the internet. Then this will connect to the smart account. He will get the detail from there. Then he will get the vBond IP from there, and he will go to vBond. vBond will check the certificate. When we buy this from Cisco will install the certificate here. Already they will install the certificate. Just we need to bring this one and install in our solution. And also we have the golden plan, silver plan, like this. When we take the high configuration, high pay plan, Cisco team will come and they will deploy this one. No need to do anything. Or if your organization want, we can deploy and we can do the configuration also. When we finish this configuration, it will connect to vBond. They will check authentication by using TLS protocol. If everything is okay, this guy will give this location and this location. So this connection will be disconnected and he will have the direct connection with vManage, and vManage is going to give him all configuration. Then he will connect to the vSmart. Always he is connected to the vSmart. Whatever update he have, he will send to vSmart. All the guy will send to all update to vSmart. This is a brain, and whenever if any traffic need to go, he will check and he will send that instruction. If you want to go here, you can use this path or that path. So we will have this this way connectivity, and vManage we can access with GUI, and we can analyze the traffic also. SD-WAN router is nothing but VH. We will install in each branch wherever we want to connect to the wherever we want to connect our route to SD-WAN solution. We should have the SD-WAN router. So each branch should have at least one. Generally we will have two. In the real scenario we will have two VH. One will be working, one will be standby. They will configure this scenario. If anything go wrong, this will be working. So we will have the two in the real scenario. And mostly this controller will be in the service provider area only. We are not installing, just we are taking the solution from the service provider. They are maintaining the controller. But if your organization is very big, they want everything, we can request the what we can say service provider. They will install this also in your organization. But most of the organization, they are not taking care about this one. This will be in the service provider only. Only we will have this one, and we will have the connectivity. And we can request with the service provider. They will give you some login details, so you can log in and you can monitor your network. So what else we have here? Now I hope you know what is vManage, vSmart, vBond, all that one. And here we have the WebTela, and the transport layer will be 3G, 4G, LTE, MPLS, anything we have. And what we will have by using the SD-WAN, we will have the lot of advantage. We can monitor from the single point. No need to log in individually. You need to log in the control, what we can say, GUI of this guy, GUI of the vManage. There is a template, ready-made template. Just go and change the configuration and apply. Example, you want to apply some configuration to this VH, this VH, this VH, this VH, this VH. Configuration will be same, only IP will be different. So you will create one template here and you will send that one. When you send that one, it will go and it will stop. It will ask you for this device what is the IP. So you need to select this IP and then click again. So this will go here. And second time they will say you give the second IP, just you will select that IP, it will go. We can do that lab, but you need to have at least what we can say 128 GB RAM. If you have this much RAM in our laptop, we can do the lab, because this vManage is consuming 32 GB RAM, and this vSmart also consuming 60 to 32 GB RAM, and this one guy will take me like 16 GB RAM. So we need nearly above 100 GB RAM to do this lab, but we don't have this lab in our syllabus. If you go separately for SD-WAN subject, there you have the lab, and lab is very simple, only some basic configuration. After that you will play here only in GUI, just you will push the configuration, it will go. To look that one, we should have at least 128 GB RAM to do that lab. Images is available, I have these images, but no use if you don't have this much lab. We can do in the EVNG, but we need this much RAM. We can install in the Google Cloud or any other cloud. We need to what we can say, we can install EVNG and we can do that one, but not necessary. Just concept is important in the CCNA level. Just you need to know, like in the traditional network you have issue, you need to do manually each and everything one by one. Here you are doing from the automation, from one point you are doing that one, and you have the problem you can see, and also you have the solution also. They have the what we can say, bank of question bank. Here whenever you have a problem, they will suggest the answers. You can click and read and you can perform that operation. Okay, same thing here also I mentioned. So with this one we finish our 3-tier architecture and all this one. This is theory only. Here if you see principle of this one, SD-WAN, control plane, data plane, traditional WAN and SD-WAN. So traditional WAN means manually whatever we are connecting. How we will connect traditional? Traditional, maybe you will take one router here, you will take another router here, like this. You will have one branch here. Imagine this is the Jeddah, you will have one branch in Jeddah, you will have another branch in Riyadh. How you will connect? You will take the lease line, virtual lease line from the ISP, or if you don't want to take the virtual lease line, you will take the internet connection from the ISP. This is ISP cloud. You will configure the VPN here, you will configure the VPN here. That is traditionally you will do this way, or you will take the virtual LAN, or you will configure MPLS, VPLS here. With that one we will do the traditional way. But now we are having the SD-WAN, so no need to have so many configuration, easily we can manage. Here we are unable to manage. We have the SNMP, simple network management protocol, but not like SD-WAN. In SD-WAN we have lot of solution. We can run the configuration, we have ready-made templates, we can edit the template and send the template. That is available in the SD-WAN solution, not in the traditional. Same thing like here also, SD-WAN and the traditional campers. Like in our local area network, how we will have our network, like we same thing just now what I created here. If you see, let me show you in the packet tracer. I think I have that diagram, this one. Here you don't have any controller, anything. Okay, you have HSRP here, but how you will monitor? Maybe you have here SNMP, simple network management protocol. In this one you will have the logs, or you will have the syslog. So you will have the log here. But how you will rectify? If you want to send one configuration to all the device, how you can send? You cannot send. You need to take one by one SSH or telnet and configure. You will write in the notepad, you will copy paste, only you will change the IP, but you need to access device one by one in the campus network or the enterprise network. But now you have the SD access, you have the controller is connected here, Cisco DNA controller, SDA, Cisco DNA center. From this you can access this controller. From there you can create template and you can push, it will go to all the network. That is the difference between the traditional and the SD-WAN access. This one I put in notes, later you read this, you will have idea. This all in this one I mention all the points here, so you will have the idea also what are the drawback, advantage, disadvantage. And we will learn more thing here. If you see here in the here we will have some basic, here they did not mention, but we will start from basic. What is a traditional way and what is the automation way, we will discuss that one. I prepare notes already for this one. So when we start automation, we will not jump directly to the Python. First we will check what is traditional network, what is the automated network, what is the advantage, what is the disadvantage, we will discuss there. And if you see here also we have Cisco DNA, and here also somewhere they mention, so we will look there. Describe the Cisco DNA workflow by applying network configuration, monitoring and management. So to complete this one, we will access the DNA center. Cisco give us one dummy account. dummy devices, we can log in and we can check this operation, what is there inside. So no issue, we are going to check that one also. So now what we learn, let me show you before stopping this, 2-tier, 3-tier and the fabric capacity planning. And in that one we have the 3 plane, this one data plane, the control plane, data plane. After that we say SD-WAN, SDAX is in the LAN network, SD-WAN is the WAN network, and what are the component, what is the plane inside that one, we discuss that one. What is the difference between traditional as well as what is the difference between our SD-WAN. SD-WAN centralized location, solution will be in the centralized. Here manually go one by one and do that configuration. So I hope this is clear now. So in our next class what we can do this one, high availability techniques such as redundancy, HSRP, SSO. This one and this one are similar only. If you see, let me show you where we have HSRP. One side they give theory, other side they give configuration. This one, if you see this redundancy protocol, HSRP, here they put VRRP. In our CCNA we have HSRP, but we don't have VRRP. Now we have the VRRP also. So this configure HSRP, VRRP in this one, and here if you see theory about the HSRP, FHRP is nothing but HSRP only. So here is theory, this is some theory topic, small also. So we will first finish this one, then we will do the configuration in this here. So in our next class we will do that one. Then we have some basic topic, NTP as we discussed in CCNA, similar topic, NAT, PAT. So some basic, or after that we can start the BGP also, BGP configuration.